For those of you who've just come in, there's a warm-up problem on the board, so you can go ahead and get that started. Oh, what do you exactly want them to do with the problem? Do you want them to describe the shape or
sketch it? Yeah, this section's on sketching.
Okay. So,
There we go. That looks a little blurry. Let me see if I can clear it up some. Where's the autofocus? All right, it's 8:10. I'll give you guys a couple minutes and we'll do this together. It was in the lecture videos that we we're going to do today, but it's worth giving it a try, seeing how far you can get without it. All right, so before let's dive into do this one, and then I'll give you some information. We can set each one of these to a constant and see what happens. If I set x equal to 0, I've got y squared plus z squared, divided by with a coefficient. You got a coefficient on it. But two squared things, the only way we're going to get a squared thing to equal 0 is if they're both 0. So we're going to have a point at the origin. We'll have a point. So maybe using x equals 0 isn't a good one. What happens if I put in x equals 1? Then I got 1 equals y squared over 16 plus z squared over 4. What kind of shape is that?
An
It's
ellipse.
an ellipse. Yeah. Where the y will be between -4 and 4, and z is between -2 and 2. And that is why I use a bar on my z, because they sure as hell look like 2s when I don't. What happens if we put y equal to 0? Let's just check what happens. I get, maybe I'll go a different color for now. No, we'll keep going with that. I get x equals z squared over 4. What kind of shape is that?
I'm hearing a parabola.
It's a parabola. So if because I realize this isn't necessarily the easiest thing you're used to dealing with. When you see something funny, like when you're working with Z and you're not comfortable doing it, one helpful thing you might do is go, well, what if I said this was y equaled x squared over 4? Well, then that's a parabola. So this is going to be a parabola just in the xz rather than in y. So that's one way of looking at it. And it's clear if we do the same thing with z equals 0, we got x equals y squared over 16. We got another parabola here. So we got parabola, parabola, ellipse. It might help to focus on the ellipse. Because that's the one that's different. So we're going to be doing ellipses where x is constant. And as a reminder, x goes in and out of the page. Can x be negative?
No. I'm hearing
No.
nose.
So it can't be negative. So when we're graphing it, it looks like we're only dealing with stuff on the positive side of the x-axis. And I will rewrite the equation here so we have it real quick. And we saw when we were at the origin, we had a point. Let me do that component as well. And when we know when x was 1, we had a parabola where y was going left and right 4, and z was going up and down 2. So if I extend it 1, rather than having a point here, I'm going to move down. Like the way I'm kind of doing it, this is how I do it. I'm using a ruler just to illustrate the idea. I'm trying to do the center here rather than the center here. It's easy to sketch when the center is at the origin. Like if I was just doing it in the YZ plane, doing it where x is 1 and the x equals 1 plane is a little bit more of a pain in the butt. So what I'm doing is I'm going down and to the left about this much. All the points that I would do in the YZ plane, I'm going to do the same thing. So here, I'm going to try to follow that same angle. I'm going to, rather than having it here, I'm going to come down right about there. And I'll do the same thing below. Trying to keep that same slope. And however far left and right I went here, I want to go left and right that far. So let's find something small because that's too big. So about that far, I want to go that far here. And I want to go that far there. And I think I could do some more ellipses, but I didn't give myself a lot of room. And I don't know that that's going to help that much. We did note that when we held y constant and z constant, it made parabola. So like when z is constant, the parabola is going to go like this. And when y is constant, we don't have any left or right. It's going to kind of go like, and this is coming directly towards us, so it's a little hard to draw that part. So maybe trying to show another circle going around them. I don't know that that's going to help any. Again, that just ends up looking like shit, right? That's garbage, right? This isn't an art class, okay? The big thing is here, trying to practice it. And your biggest takeaway from these first three sections we're doing this week, 11.1, 11.7, and 11.8, is you're learning you're developing skills to visualize what's happening in three-dimensional space when you're working with equations. When we do the test, the only type of equation I'll really test you on is probably something in chapter or 11.1. I'm not going to give you something like this where it's really hard to sketch. It'll be something simple because this is not an art class. And if you were going to graph it in real life for anything useful like engineering, you would use a computer. You would not, your boss would fire you for shit like this. So if the graphing is discouraging to you right now, and I suspect it is because this shit's hard and it's easy to go, that looks terrible. I know mine looks terrible too. I'm not an artist. If you're an artist, you might be able to make some great shit here. In fact, if you are, send me some pics of what you're doing. I'd love to see some really well-made graphs because I'm not good at doing them myself. Don't get discouraged. The idea is to get a picture of what's going on.
And for me, what I ended up doing, I still do kind of do this. I end up doing a really rough sketch of the graph first to get an idea of what it looks like, and then make a nicer looking graph afterwards. So I don't even get it done in one graph.
And it might help since this is coming out of the page, this one's a little hard to picture coming out of the page, but we do know it's there are ellipses. So maybe if I did something like where I could see it a little bit better, like ellipses going upward like this, and I know that's making a parabola like that. Apparently my circle isn't well enough. I'm making like this cone that doesn't have a point on the bottom. It's curved at the bottom. Nope, that's not true. It's a point. No, it's parabola. We already looked at that.
It's still curved. Yeah, it's still curved
Yeah.
at the beginning. It just has a point that it converges to.
Right. And when I write it vertically like this, it's a little easier for me to picture that it's kind of like a dish, but facing towards me. So don't get discouraged by the graphing. It's not the biggest part of this section is getting some practice in working in three-dimensional spaces and getting comfortable with X coming out of the page, Y going to the right, Z going up, and trying to get a feel for what's going on. Okay. Any questions on that one? Okay. Another one we had on the little video to give a try would be z squared equals x squared plus y squared over 9. So what I'm going to do is similar to what I was doing on the other ones and what I did in the video. I'm going to go through each of the letters, zero them out, and see what happens. If I zero out x, I get z squared equals 1/9 y squared. And if I took the square root, z equals plus or minus 1/3 y. That's going to make an x. Those are two lines crisscrossing. If I do the same thing with y equals 0, I got z squared equals x squared. And so z equals plus or minus x. And you take the square root of both sides. Again, crisscross lines. That looks like an x, so maybe I'll do that. So those two cases are similar. Usually the one that's on the other side, or if I had it on the same side, z would be negative. That's the case we want to look at. So let's see what happens when we zero out z. Well, just pretend it's zeroed out. If z equals 0, I've got two squared things adding up to 0. They both have to be 0. You'll get used to that being a thing. It's a point at the origin. So maybe looking at z equals 0 isn't helpful. Let's just jump out a little bit. Let's go to z equals 1. If z equals 1, I've got 1 equals x squared plus y squared over 9. And this is back to the ellipse. So this is similar to the other one. We've got an ellipse coming. It's not coming out of the paper. It's going up in the z direction. Can it be negative?
Yeah. I'm hearing yes.
Yes.
And now I'm
Yes.
hearing yes.
We can see right here z can be negative. And that's simply because we have the square now. If it wasn't squared, z couldn't be negative. Since it is squared, we can have a negative. So let's try sketching this bad boy. I'll rewrite this down here. And we already know that we're going to have, it comes to a point, because these are crossing in points. It's going to be like an hourglass shape, but not circular. So let's try to give this a sketch. And what kind of shape would we, oh, we know we have a point at the origin. And we know that the shape of the ellipse at x equals 1 or z equals 1. I'm going to do vertical or black lines for the graph part. The major axis is going to be 3. We're doing the, if you forgot, we take the square root of that bottom number. Square root of 9 is 3. We're going to go left or right 3. 1. Doing it again. All right, so up 1, we're going to go left or right 3. Put a point there, put a point there. And along the x, we really have a 1 on the bottom. So the square root of 1 is 1. We're going to come down a point this way and up a point or into the paper that way. Again, I'm following an invisible line that is parallel to the x-axis. And I'm trying to just do the same increment I did here, doing it here. So this, you get more comfortable doing it. It's not the easiest thing. but it does get better with time. And since I know it's negative, I could do the same thing going downward. So let's go down a point, and we'll go left 3, right 3, in 1, and along that parallel line again 1. All right, so, and we know they come into a point. So this point should pass through the origin and come out to this side. Just like this point and this point, they're opposite sides of the graph. I'm looking at just I'm leaving X alone. I'm looking at the Z and Y lines right now. I know it comes out from here and comes upward like that. It's making the cone that way. And we got one going like that one also. And this should come downward like that. And we got another one going back there. That's like that. So it's a little hard to picture with the way I got it. It might be easier without having the graph there. I know it's making a shape like that, and it's making a shape like that. Because it's making ellipses, and it should be like a two snow cones stacked, one on top of each other. Which makes it, I think actually this is a better graph than this. So when you know how the graph should look, it might be easier at some point to just go, okay, let's add axis to this kind of thing. The idea is you're getting an idea of what it's looking like. And I think doing all the trace lines might actually make it a little bit harder to do. Picturing ellipses that get larger as you go upward and getting larger as you go downward, but near zero, they come down to a point. I think you can picture that what we're getting is something like this. We've got ellipses that are getting bigger as they get away from the origin. And since they meet in cross lines, it doesn't have a parabola-like effect. They're straight lines. Again, it's not the easiest task. In reality, in your job, you will not do this by hand. It is more for your ability to learn how to visualize stuff in three-dimensional space. Okay? Are there any questions on this one?
Yes.
I'm not sure how you came to the conclusion that Z equals plus or minus X is the cross.
They're confused on how you got the plus or minus X. So you're talking about like how square roots cause that?
Oh no, not that. That's not. I understand where you got that. I'm just trying to figure out how he got the shape of the X.
He was confused on how you.
The ellipse part, the X in the ellipse part.
Oh no, not the X shape, like the graphically.
He's confused how you got the graphically shaped X.
The ones that you can see that are in the page that do not come in and out of the page is that line crossing with that line. That is the Z and the Y. This is the Z equals plus or minus 1/3 Y. Z equals plus or minus 1/3 Y. Doing the Z equals plus or minus X, it's just hard to graph because the X is coming out of the page and going into the page. So unless you're really good at this shit, it's gonna look crappy. But it does help to kind of get an idea doing one shape at a time, just doing that first, like when I just did that first ellipse and there was nothing on there, following the x-axis and going, how far would, if I was just doing a normal ellipse, and it's 1 this direction and 3 this direction. Now, if I move it, how does that make the ellipse move? Well, that point's got to move down. That point's got to move down. And I think I should have moved my, no, because it was z equals 1. We were fine. And so that's how I was doing it like that. Again, my graph may not be the best. It's a work in progress. You're not going to find a math teacher that's great at this. It's really hard to draw them. We can get adequate. Some of these I'm a lot better on than I am at others. And as Brandon was saying, sometimes that first sketch, you're like, oh, that looks like shit. Maybe I'll sketch it again now that I know what it looks like and go from there. So maybe we can do that here. And X. Okay, so I know it should be making like a cone upwards. And so maybe putting in the ellipse going upwards where it's 3 times wider than it is long. Let's see, let's go from there to there. And since I'm going into the page, it doesn't look, the ellipse looks a little funny because I'm going into the page. It doesn't look exactly like a regular ellipse, but that's the point I'm crossing there. I'll come down here and do the same thing down here. Let's see, that much, right there. I want to go out about the same distance. My first graph, I had too much shit close to the origin, but now I know in the ZY plane, the 1/3 Y is going to go like that. So I'm connecting that point through the origin with its opposite on the other side. And I will do the same thing with these 2 points. They're on opposite ends of the Y side, left or right. And we know the line through them has got to go through the origin. And I might add just a single more line showing that it's going in and out, maybe by putting a point on the back side of the arc and going diagonally and putting a point on the front side of the arc, and maybe showing a dash line in the back and a solid line in the front. That way I can show that it's going in and out of the page. The dash line usually is often used as going into the page. You're in the negative area. And that's, I think, a hell of a lot better than my first graph. There's that piece of shit. Here's that one. This one looks a lot closer to that.
Artiste. Artiste indeed.
Is that good? Does that make sense?
Drawing.
Yeah, that's a lot more clear.
Okay, so yeah, you're not, as Brandon was saying, draw it once, see what it's supposed to look like, then go, this is a piece of shit, throw it away, draw a new one. And now that you know what it looks like and what's wrong with the graph, sometimes, as I showed here, sometimes using more, I was trying to save paper, using more paper, spreading that out, making this, you know, one up here makes it a little bit easier to see. And again, there is more graphing in the class, but it's not a lot. And you're going to have to graph like really one thing in this class on this first test. The rest of it is doing it to visualize what's going on. If there's no more questions, let me let you guys work in groups for a little while. Oh, before you start, one thing I want to let you know. I know of one student that has jury duty this semester. Many of you are young and don't have experiences with this, or if you have, you just assumed it was something you had to do without question. As a student, as a teacher, they know how much one jury assignment can screw up learning. So if you get assigned jury duty, they give you a number to call. You can call the number as soon as you get the paper and say, hey, I'm a student at College of the Sequoias. I'm taking some three-dimensional calculus bullshit. I probably got some physics and some engineering. I've got a lot of stuff. This is really going to injure my grades. It's going to ruin my grades. Can I defer my jury duty till after the semester? And if you ask nicely, without question, they will, okay, when is your semester over? And they'll schedule it for after that. So that you don't have jury duty screwing up your class. That's just a pro tip. You learn that the hard way going through life, that sometimes you just have to ask. The worst they can do is say, no, we're not going to defer it. And then you're back to where you are if you didn't even call. It's not like they're going to penalize you or anything for asking. So sometimes asking helps. All right. Practice your graph.
See if I can. All right. So I'm gonna actually show you. Oh,
let me stop sharing so you can share.
yeah. Is it where? Is it on the screen? I don't know how this works. Oh, this one. I think. Let's see if that works. It's white. Oh, it died. That didn't work. Oh wait, where?
It's sharing your
seem to-
camera. It's not sharing
Yeah.
the PC thing.
I'm trying to share the top head. Oh, that's the second. I see. That's what that is. Share screen. I'm not completely sure how to share it.
Okay.
Oh well. Oh, this is upside down.
If
So-
when you're trying to do share screen, Brandon, if
Yeah.
you take a picture of it and send it to me on the phone, I can look at what you're looking at, and then I can
Oh,
invite
okay.
it.
Well, so this is some example of what I was talking about. As you can see, this thing is ineligible bullshit, but this is a little easier to read. It's the same with these here. Don't mind the So you can't read this, but this kind of looks okay, right?
You tell.
Right? I'm good artist. I'll send it to you in the chat real quick.
Okay.
Give me a sec. Oh gosh, what did I do? Hey, it looks better. It doesn't look like just scribbles, at least. That's the important part. All right, let me see what I can do about getting a picture. Let's see.
The most important part is that you can actually see whether or not you can draw it on the page. You can kind of visualize what's going on.
Yeah.
So when you're sharing screen, it gives you a list of options. Just take a picture of it with your phone.
Yeah, that's what I'm about to do.
Okay.
I didn't think of it. I got to 5 and then I was like, there's no charge on the string one.
All right.
That might be accurate.
Yeah. That your.
I didn't put it over, but I think it looks something like
For the first question.
There you go. I'm just texting it to you. It might take a while to get to you though.
Okay.
that. For 11. Yeah. No, I haven't yet. I didn't get a chance. I need to ask a question, but I think I need to actually show them what I did to see if I could do this.
Can I take a look?
So 7B. So 7B right here.
Mhm.
So instead of actually, so I set everything as to a constant to figure out what my, so when I set z equal to 0, I know that it's going to be a point of the origin, right? When I set y equal to 0, I'm going to have a parabola. It's going to be like a normal parabola. And then when I have a x, or when I say x equal to 0, I know I'm going to have a parabola that's going to be skinnier because there's a 4 over here. So, right. So my question was going to be, was because when I actually have the ellipse, right? Because the ellipse is going to form up here. I don't actually define it by setting z equal to a value greater than 0. I just simply put the point on the origin and did the parabolas. If I just did it like that, would that be okay? Or do I actually need to define like where at z that ellipse is actually formed?
There, you do not need to. That ellipse is just defining what the shape is looking like at that point, because technically there is like infinite numbers of ellipses throughout this entire all the way up until infinity. So you're fine.
Okay.
That's just a way of getting an understanding what that looks like.
Yeah.
We did something similar.
One I got.
Oh, I'm jealous. Yours definitely looks better than mine when I was there.
I think I still kind of just want to ask, just like make extra sure. I don't want to do this on like a test, for example, and then like I don't know,
I can confirm it with them.
I get knocked points.
So I'm getting a question about whether like when he's defining a when he's creating a graph, he's wondering if the ellipse that's defining the graph, like a certain point of the paraboloid, if he needs to define where that ellipse is.
According to Z, the homework problem is 7B. If you need to look at what I'm talking about, 7B in the homework.
Yeah, let me grab the thing. Brandon, in terms, the thing hasn't come through, but it occurred to me, if you share screen, and then on the document camera, remember the buttons along the front row in the front? That switch screens, that might work as well. That might switch the share screen to that. Let me look at 7.
This one? Oh, this is just not on. I probably should have that on.
It's the big document camera, the thing on the right. It had PC.
Yeah, I see it. I'm switching it. I forgot to turn the thing on.
And then that should go through the document camera, which is the big gray thing, not the black box. Let's see, 7B.
Can you read this section?
No, yeah, I'm gonna switch this as well. Okay, that's there.
You're trying to read.
Okay. Oh, okay. So that's gonna find a way to get there. Maybe. So the second camera is this thing, I think. So
just make one
screen.
nicely. Click the whiteboard.
The whiteboard?
Yeah, I think whiteboard and then do share.
No, that gives me just straight up whiteboard.
Oh, okay.
I can see that though. Now I'm seeing the whiteboard. If you were to put
Yeah,
your
it's
page
the-
over that. Oh, that's the whiteboard, not the camera.
Yeah, it's the whiteboard.
I thought.
Okay, do the regular share screen.
Okay. Let me share screen. Okay. I could do the
Turn on that big
screen.
gray document camera on the right, where you would write with the white, not the black box, the white flat thing on the, that thing, the
Yeah.
thing you're looking at now. If that's on and you change the camera over to the document camera or switch them, it'll change between showing the PC or the document camera, and it might work on share screen.
That's what I'm looking for.
In
portion of
terms of
screen.
the question on 7B with the ellipse and showing the thing, the biggest thing you want to kind of do is show the relationship between the X and the Y. Like the Y thing, when you do the square root, it's going to be the square root of 1/4 is 1/2. So the Y should be like half as wide as the X. If you
Right.
don't need to like draw the actual marks, as long as you have that relationship where you can see it, it should work.
Yeah, here. Actually, maybe I'll just show the
Yeah.
Here, so if you just, I don't know how well you could see what I did. So seven B's right here.
Let me
It might be,
give me 1 second to make yours big screen. Okay.
it might be inverted. I don't know if it's like,
He's just making the camera itself bigger, probably.
No, that looks good. That's actually really
yeah.
good.
Yeah, so basically what my question on that was just to make sure, because so since I set all the values equal to 0, right? I know that when I set z equal to 0, that I'm gonna have a point at the origin. And then when I set all the other values to 0, I know I'm gonna get parabolas, depending on the z, y, zx plane, and then how wide it's going to end up being, because obviously since you have a 4, you're going to have a parabola that's going to be a lot skinnier than if you just had a regular like z equals x squared graph.
Right.
My main thing was because I didn't actually set a point, so I didn't actually say like at z equals 1, these are what my points are going to be. I just simply figured out what the initial point was, which is at the origin, and then found the rest of the parabolas, and then drew my ellipse off of that. Would that be okay on a test?
Yeah.
Okay, sweet.
The reason why I do the setting the z equals 1 and shit like that is sometimes that's easier to, once you've eliminated one of the variables, you've only got 2 variables left. It's a little easier to picture what the hell is going on.
Right.
And that's why I do it. Actually, walking through it, it's not really necessary.
Okay, sweet. Thank you.
Yeah, I guess you'll have to help me figure it out here when you come here at some point, because I couldn't find it. The only one that was there was like the dot cam, or not the dot cam, the camera that's actually looking at me.
Okay, so I'm gonna draw. This is gonna be terrible. I'm gonna try drawing it.
Could you repeat that? I didn't quite hear you.
I'm gonna try drawing what. Okay, so you got the computer here with the keyboard there. That's the computer and keyboard. There's that little black box here. Document camera is right here. And it's got the 2 bars that come up. One shoots light, one records. And it's right here. There's a little panel. And it's got little buttons right there. When you're sharing screen and you've got the document camera on, like you turn the power button on right here. There's a power button.
Yeah.
You turn that on, it will share screen to the projector. Clicking between these buttons might allow you to share, like put a piece of paper.
Yeah, so I have
right here and project it.
And I can switch it between the dock camera and the PC, but that only shows on the projector, not on Zoom.
Okay, so when you click share, okay, so right when you click share, it gives you a like. Well, I'll take you a picture of what I see.
Say it again.
Hold on 1 second. I'm showing you. Okay. I'm sending you a picture. Okay, I sent a picture. This is the intermediate step between sharing screen and actually when I click share screen and when it actually shares my screen. I'm kind of curious what it shows on your screen when you do the same thing. When you click share screen, what options does it give you? If you take a picture of it, I might be able to help.
Okay.
Now, let me turn off that shitty whiteboard.
Would you, thank you. Not great pictures, but
Well, cardboard box has it's called a box. So you can call it equation.
Yeah, give me a sec.
Puts into the cardboard box.
All right, I'm sending them over to you.
Okay.
All right, someone had a question?
These slides are really unique though.
That's good.
I understand you're like three type of slides.
That's obvious. I don't know. I'm not even gonna, I mean, what, I just, I don't.
That just sounds like you
Okay, so I think it was just, okay, look, so for A, right, when it's 0, obviously that's gonna. So obviously, it's gonna leave you with 1 squared.
So you're asking like
Yeah, why can't we make C? And right here, you just made everything, you made everything positive.
Yeah.
You made everything positive. But negative one. So you had, so you just had negative. That's why.
So that's like, usually like this,
So
instead of like a Y, it's
now,
like you
yeah.
traits of.
So I understand that it has to be greater than, and also understand it has to be less than negative. So I understand that. Right?
Yeah. So the reason why is because it has been all,
I just want to have
to.
the video. That's why I get nothing.
Well, but
So it's something like that manipulate your,
yeah.
you're supposed to look at it.
Okay, if you define them as equal lever, right, negative, that is the, you have 0, and then you have something 3 plus. So it's go Y, that's saying, so an elliptic line. So.
What am I looking at?
So there's no point in drawing these.
Yeah, exactly. I'm saying like that's pretty much where, that's why I'm thinking that it's an ellipse. Yeah, yeah, so when X is 0, that's gonna leave you with 1 squared plus Z squared.
No,
So then it's
It's like, it's kind of cool, right? How about like, it's like a celery.
Okay, so you're asking what my.
But for A, that is much longer there. For 1A, that's an ellipse, right?
Okay, so I do have a question that I was struggling to answer.
Well,
The
Yeah.
hyperbola of 2 sheets.
Yeah. Hyperbolated.
So someone was wondering why Z can't be 0.
It's from the lecture.
Yeah, they were saying it's from the lecture video that you had.
Okay, let me grab the lecture notes real quick. Okay, so I'll take the whiteboard down real quick. Actually, yeah, it's easier if I take the whiteboard down. So the question was, if we've got, this is from the lecture notes. If we've got x squared plus y squared over 4 equals z squared minus 1, why, is that the one we're talking about? Why can't z be what? What's the question again, Brandon?
They were wondering why z couldn't be 0 because in this situation z can't be has to be
Okay.
greater than 1 and less than
So-
-1.
Let's look at the equation. If I make z equals 0, I have x squared plus y squared over 4 equals 0 minus 1 is -1. This is a squared number, which is always greater than 0.
Someone had a question over here.
That's a squared number, which is always greater than 0. So I'm adding two positive values. How can I get a negative number if I'm adding two positive values? That would be why z can't equal 0. We have the restriction, since they're both positive values, this has to be greater than or equal to 0, which means z squared minus 1 has to be greater than or equal to 0,
Okay.
because that's the right side.
So I was the one who had asked. I think the reason why I had gotten confused was because in the middle or during the process, you said you multiplied by -1, and since you converted z squared minus x squared minus y squared over 4 into negative z squared plus x squared plus y squared over 4, I assume that you applied the -1 to everything. So wouldn't you have to do the -1 on the opposite side as well?
I did. I kind of went through the steps a little quickly. Let me go it a little bit slower. And I can avoid doing the -1. If I divide by 4, I have this. Right?
Right. Yeah.
Let's add x squared and add 1/4 y squared to both sides. And I get z squared. And let's subtract 1 from both sides at the same time. I'm going to get z squared minus 1 on the left equals x squared plus 1.
Oh, okay.
So that's the same thing as doing it, but if I multiplied by -1, it just changes the sides here, and I moved the different things.
Okay, yeah, that makes a lot more sense, because in the video when I had heard you said that you multiply by -1, I did that, and since I did it on both sides, I ended up with x squared plus y squared over 4 equals z squared plus 1. So that's why I was getting confused on the values, because I was like, well, wait a minute.
You
'cause
didn't
also have
multiply the 1 by the negative.
Yeah.
You should have
Or
z
no,
squared minus.
well, no,
That's what if you had z squared plus 1, you missed
yeah,
the 1.
I did, but for some reason I changed it back into positive. Okay, so I see the mistake about why I'm confused.
It's awesome. I'm glad you asked. Thank you guys for asking.
Yeah, no, thank you for clarifying.
I think we gotta let the next class in if there is another class.
Say it again.
There might be another class. Brandon, if you click on it when you're doing, let me turn off share screen. We might be able to figure this out real quick.
Okay.
Click share screen, click on the advanced thing at the top.
Yes.
What kind of send me a picture of that.
I did send you a picture of that, I believe. That
You
was with
sent
the
me a
two
picture of
pictures.
the basic screen. If you click
Yeah.
advanced, it should have different shit. Or was there?
Yeah, no, I have I sent you a picture of that as
Oh
well.
shit, you did.
Yeah, so the content from the second camera, that's what brought up my camera. The camera that's looking at me. And
Okay.
despite that looking like an overhead.
Shit. Okay. I'll see what I can figure out now that I know. And I'll get back to you tomorrow about it. I'll go
All
through
right.
and try to find.
Cool. I'll see you later.
Okay.
Did you have any more questions?
Yeah, just one last question, Professor. So
Yeah.
on that same problem, is there any reason why you chose to isolate the z to the opposite side of the equation instead of a different variable, or is there any reason why?
It had the opposite sign of the other ones.
Okay, so you knew that would be a way that you could make the pretty much everything positive with the exception of the -1, just so it's easier to understand,
Yeah.
basically. Okay.
It's easier to
okay,
understand when everything's positive like that. Exactly.
right, okay. Sweet. Perfect. Thank you so much, Professor. See you tomorrow.
What's your name? So I remember because you asked questions.
Sebastian Gonzalez. I'm also
Sebastian.
the one. My name on Discord is Omen, because I never use
Oh,
Discord.
okay. You're
Yeah,
Omen.
I was the
Okay.
one who was messaging you yesterday about just the different stuff.
Right. Awesome. Great, Sebastian. Keep asking good questions. I love it.
Yeah, thank you. Have a nice day.
I'll go ahead and